Good morning. Sorry for the lighting this morning. I'm in a different location than I've been the past few times, and I have the light coming in from behind me, so it's going to be a little bit more difficult to see me. But basically, what I'm doing today is I'm going to go over the answers to the questions that I've assigned you this week, and if you have questions on it, you can post them, and then in next week's Zoom lessons, I can address them. Okay. Starting with question number 1. The oxidation number of an uncombined group 2 metal is? Well, it's going to be 0. Uncombined. I know group 2 is positive 2, but that positive 2 is when combined in compounds or as an ion, right? There's rules. An ion is equal to the charge of the ion. As a metal, it's in its elemental state, so it's going to be 0. Okay. Question number 2. Both mass and charge, choice 4. Redox reactions balance for mass and charge, and also energy is conserved, but we don't discuss the energy conservation during a redox reaction, but it is. Number 3, write down the letters G, capital E, capital R, all together, GER. Remember I said Leo says GER, loss of electrons is oxidation, gain of electrons is reduction. Okay, the answer is choice 3. I don't like some of the wording that they use here. It says gain of electrons, that's the GER stuff, okay? But in reduction, the oxidation number goes down. So it says loss of oxidation number and gain of oxidation number. I think the wording is confusing. They probably do it, excuse me, they probably do it on purpose. But despite the wording, the answer is 3. Loss of oxidation number refers to the decrease in oxidation number, which is the way that I've explained it. Number 4, it's the electrons that are lost and gained. So the number of protons are going to remain the same. Okay. The species reduced, so it's GER again, gains electrons. And if you notice in choices 3 and 4, it says something about reducing an oxidizing agent along with loss of electrons, which makes the answer wrong. So neither of those would be the case. If we wanted to address that portion of it, for choice 1, we can write gain of electrons and is the oxidizing agent. Remember, the one that is reduced is the oxidizing agent. It's when they put the word agent, it's the other one. And even though they didn't ask that in the question, it's good to review it. Number 6, total number of electrons lost equal total number of electrons gained because of conservation. Okay, the answer shows 1. Number 7, function of the salt bridge. Remember I said it's for ion migration, so it allows the flow of ions. That's the ion migration. Number 8, which of the following occurs in an electrolytic cell? The electrolytic cell requires the electric current, okay, to produce that chemical reaction, so it's choice 2. Number 9, hydrogen in its elemental state. Remember, everything in its elemental state is 0. The only one that really doesn't exist in its elemental state is francium. Remember, francium is so active that it's never found with its electron. So francium would only be positive 1 under all circumstances. And then fluorine is also rare to be a negative 1 because it's also very, very active. Fluorine is pretty much negative 1 whenever found. But hydrogen is found elementally, okay? And it's found as a positive 1 and a negative 1. So 9 is 4. Number 10, the voltaic cell, the cathode is positive. Remember, in the electrolytic and electroplating cells, the cathode is negative. Half reactions 2, balance for mass and charge. I think it's the last question here, or one of the ones in the 20s, where we have to pick a reduction reaction, and it uses a diatomic. So there's going to be 2 electrons and 2 ions formed. That's to balance for mass and charge, and I'll come back to that when we go to the other question. But number 11, they're going to be balanced for both mass and charge. Number 12, which reaction occurs at the anode? Anode is oxidation, and that's in all cells. Anode is always oxidation. Voltaic, electrochemical, electroplating, rechargeable, battery reactions, all of them. Okay, 12 is 2. Number 13. Okay, by rule, okay, going in the order of the rules, Na is group 1, so it's positive 1. We skip the group 2 rule. We come to hydrogen. Hydrogen's positive 1. Then we come to the oxygen rule. Oxygen's negative 2. Weakest rule here is carbon. We're going to calculate for the carbon. Keep in mind you have 3 oxygens that actually make negative 6. So carbon has to be choice 4, positive 4. Number 14, I'm going to calculate the oxidation state in chlorine for all 4 choices. You're actually going to see a very, very relevant trend. Okay, the hydrogen is positive 1 by rule. Oxygen is negative 2 by rule. And it's going to go in order for the chlorines because the hydrogens and oxygens are the same in all of them. Chlorine doesn't have the rule. It's that binary ionic rule, which this is not a binary ionic compound, so we can't even apply that. No IDE applies here. And the charge for chlorines in the choices in order 1, 2, 3, and 4 go 1, 3, which is the answer, 5, and 7. Since each one has an increase in 1 more oxygen, there's 1 more negative 2 charge. So to be electrically neutral, those chlorines have to go up by 2 each time. All right, so 14 is 2. 15, we have NH4, NO3. Going to break that into 2 separate ions. NH4, you know what, I got a little paper here. I'm just going to write it out on here and show it to you. I don't have my board with me right now. NH4 equals plus 1. NO3 equals minus 1. Okay, you can see that. NH4 is positive 1. NO3 is negative 1. That's why the compound overall is electrically neutral. Since it contains 4 elements and 2 polyatomic ions, you really need to look up the charge of the polyatomic ion to help you out with the nitrogens, since each nitrogen in this compound has a different charge. Okay? The H by rule is a positive 1, and the O by rule is negative 2. Then we're going to calculate the nitrogen in each case. Since we have 4 hydrogens, that's a total of positive 4. We need an overall charge of positive 1. That means in the first polyatomic ion, the nitrogen is in negative 3. When we go to the second polyatomic ion, there are 3 oxygens, each at negative 2, making a total of negative 6. This polyatomic ion is a negative 1. That means the nitrogen has to be a positive 5 against the negative 6 to still have a remaining charge of negative 1. With the ammonium at positive 1 and the nitrate at negative 1, the whole compound is electrically neutral. It fulfills the rule of electroneutrality. The compound overall is neutral. So the nitrogens need to be different charges, negative 3 in the ammonium, positive 5 in the nitrate. So the answer is choice 4, plus 3, minus 5. Right? If you have a question on that one, post it. I'll make sure that's one of the things that I will address in Tuesdays and Thursdays Zoom lessons. Number 16, all right? It says KClO3, choice 3 says KClO3 goes to 2KCl and then 3O2. Without looking up everything, what I do when I see a problem that asks you to determine a redox reaction, find something in one of the reactions that's a 0. There's only one case where this wouldn't work, okay? And I've only seen it on the Reasons exam once in like 30 years. So it's not something that you're going to come across. That oxygen is at 0 on the product side. The oxygen on the right is 0. On the left-hand side, the reactant side, you say KClO3. Well, that's going to have some sort of a charge. I don't even need to figure it out. If it's charged on the left and 0 on the right, at the very least, the oxygen changed. If the oxygen changed, something else had to change. That's the redox reaction. Number 17, same thing. We're asked to find 2 redox reactions in this case. I'm going to use the same general rule. I'm going to find the equations that have zeros. Go to reaction B. Reaction B starts out with chlorine. Oxidation state of elemental chlorine is 0. All right, so I know that's an answer. Go down to C. At the far right of it, I see copper. Copper 0. Copper has a charge on the other side. I don't even need to figure it out. So B and C are both redox. A and D, if you went through the trouble of assigning all the oxidation numbers, you would actually find that they do not change. So the answer is going to be choice 2, B and C. Number 18. If you go through the trouble of assigning all your oxidation numbers, again, you're going to find that they do not change. Neither gain nor lose. It's not redox. There is no movement of electrons. Number 19, it's asking about the hydrogen. This is a redox reaction. In 19, that's redox. So matter of fact, the chlorine starts at 0. In the HClO is positive 1, and the HCl is negative 1. Chlorine both oxidizes and reduces. However, that hydrogen does not change. So hydrogen is neither oxidized nor reduced. There is an oxidation and a reduction, but hydrogen is neither oxidized nor reduced. Okay, the answer is choice 4. And there's a name for something in a reaction that doesn't change. It's called a spectator. Number 20, it's asked about the K positive. K positive is going to go down to 0. It's reduced. And reduction is by gaining of electrons. So 20 is 2. 21, this is the question I was referring to before about balancing for mass and charge. And when you have a redox reaction of a diatomic, you're going to have to double up on your number of electrons and your ions in the equation. So if we look to it, if we go to choice 4, it says Br2, okay, diatomic. And that means you have to form 2 Br negatives, 2 bromides. That makes a negative 2 on the right, because each bromine is negative 1. There's 2 of them, so it's negative 2. So that's going to require 2 electrons on the left. And the last one, we're going to assign the oxidation numbers for the equation. You have Mg at 0, Cl at 0, and then we have MgCl2. The Mg is positive 2, the Cl is negative 1. Mg goes from 0 to positive 2. That's the oxidation. It's going up in charge. We have 2 equations that involve Mg, and they both kind of look like oxidations. It shows an increase in charge. However, in choice 1, the electrons are on the wrong side. In choice 3, the electrons are on the side of higher charge. Choice 3 is in fact the answer, 22, choice 3. All right, ladies and gentlemen, that's all I got for you today. I'm going to be posting Castle Learning over the next couple of days, and I'll probably give you a week. I will give you a week to do it. I'm not going to give you less than a week. And I'll probably do review sessions for it later on. I haven't worked out next week's schedule yet, but I'll do it over the weekend. And look for look for me on Edmodo on Tuesday, and I'll give you an idea of what your lessons are going to be. All right. Have a nice day, everyone. Enjoy your Memorial Day. Hopefully the weather's going to be nice. Listening to the weather this morning, and they're talking about that we have a stationary front that is right now. I think it's just south of us. So let's hope it continues to stay south, or if it's going to come north, comes north quickly tonight. And either way, we have a nice weekend. All right. Take care. Hopefully you and your families are well. Bye-bye.